By definition, the bond price is determined by the present value of cash flows from the bond. Let's take a look at the following example. If there is a 3-year bond having a face value of $100 that pays 10% coupon every year and the market rate is 9%, then the present value will be $102.53. If we want to design a C++ program that runs the calculation, there are several things that we have to consider. Firstly, there are cash flows generated from the bond every year, therefore it is better for us to use vector function to represent the amount generated from the bond every year and the number of period that the bond pays its coupon. Secondly, we should use a for loop, and the size of the for loop should be controlled by the number of period. Thirdly, instead of putting everything into the main program, we can create a function called the bond price function that helps us to calculate the present value of cash flows so that it would be convenient for us to call such function when we write our main program later. After we have understood the logic behind, our C++ program will look like this. Now let's have a closer look at our program. At the beginning we have to declare the headers we use. Since the present value formula uses the power function, therefore we need the CMath header. After we have put in the vector header and IOStream header, we then construct our bond price function. In our bond price function we first declare variables, then we use a for loop to calculate the present value of cash flows for the 3-year bond. More importantly, the size of the for loop is not a constant value in our bond price function because the size of the for loop will be determined by the number of pushback functions in our main program. In our main program, we first declare 2 vector variables for the cash flows and number of periods. Afterwards, we use the pushback function to add the cash flow generated by the bond at their corresponding locations. Remember, the names of variables in our main program do not have to match the names of variables that the bond price function declares. The only thing you have to make sure is the variables are being put at the right place inside the bond price function bracket when the function is called in the main program. If we want to tell the program to return number rounded up to 2 decimal places, we can write down these 2 lines and make sure we put down 2 in the precision bracket. However, if we did not write down the setf function on line 23, then the program will return number with 2 significant figures instead. Finally, the program shall give the present value of 102.53, and basically this is how we write a C++ program to calculate present value of series of cash flows for us. Thanks for watching. Remember to like, share, and subscribe for more. See you next time.